All right, good afternoon, everybody. As you start to prepare for your final exam, I figured I'd give you a little bit of information about it and give you a review of the last section of material. So your final exam is cumulative, and about a quarter, 25% of the questions will come from the first exam material. So it'll be the same content, not the same questions, but the same content. A quarter will come from the second exam content, and half of the questions will be from your last section. Okay, so let's review your last section. There was quite a bit of stuff in here. And just as we think about it, the way this class is set up, the first whole section has to do with the solid Earth. So how did our Earth form? What are the rocks on Earth like? So that was mostly with igneous rocks, and we had volcanism, we had plate tectonics. We formed our solid igneous rocks. In the second part of the section, we looked at the surface of the Earth and we looked at water on Earth. So water in the ocean, and then we looked at the atmosphere. So we looked at how our ocean moved and how our atmosphere moved. With our third section, what we're really doing is we're taking the ocean and the atmosphere and we're running it over the solid rocks. So it's at the interface or the intersection of these two areas, water and atmosphere and solid rocks, that we're really concerned with for our last and final section. And that's the section where people live, right? We live right at this interface. So for a lot of you, this part was hopefully a little bit more familiar than the other parts. Maybe this part will be a little bit more relevant to your daily lives. So what did we talk about? Well, we talked about the water cycle. And even though that's something that you have probably started learning in elementary school, you can increase the amount that you know about it. So the water cycle or the hydrologic cycle, and that starts with where water is located on the surface of the Earth. So obviously the ocean is the largest reservoir, and that water is salty, but you also have pockets of fresh water. You've got your glaciers, your groundwater, your lakes and streams, your atmosphere. These are all different places where water can be. And so the water cycle deals with how does the water get from one reservoir to the other reservoir. So if you start with the ocean, water gets out of the ocean by evaporating, and it then leaves the salt behind. So the fresh water evaporates out. As you learned in the last section, it then condenses and then can precipitate back out. Now, a lot of the times it just precipitates right back out on the ocean, and that just happens over and over. But sometimes it goes over the land, precipitates on the land. So you get your rain, your snow, whatever, on land. When that happens, the water will eventually come back downhill. So the two things that drive this are the sun causing the evaporation and then gravity pulling water back down. So as the water comes back down, it runs over the ground surface. Sometimes it infiltrates and runs down through the ground as groundwater. When it runs over the ground surface, it contributes to the sedimentary processes. So when it runs over and runs down, it weathers the rocks, it erodes them, meaning it's breaking the rocks up and carrying it, transporting the particles. It always transports them downstream. So it's transporting the particles. And then as the water slows down or the wind slows down, then it can deposit those particles or sediments out. Over time, those particles can get compacted or packed down as more sediments get on top of it, and then that can lithify to become a rock. So this is how water drives the sedimentary processes. Wind can also do it, but water really is the big driver for those. So that's one reason why the water cycle is so important to us, is it really drives a lot of our sedimentary processes. Okay, as it comes down and as it affects us, water is affected by the drainage basins. So these are areas where water falls into. You can think of it as a bathtub, a drainage basin being a bathtub. And any water that falls into that bathtub is going to come down to the drain, right? So that whole basin drains at one point. If you have a child like mine who likes to splash, or you pour water outside of that tub, there's a high area of elevation around the tub, that's a divide. If you pour water on the other side of the divide or outside of the tub, then that water is not going to get to that drain. It's going to be in another drainage basin and it would go somewhere else. So these are important. We also learned about the sedimentary rocks that form. So there were a few different sedimentary rocks that you looked into. Some of the most important ones were shale. I do want you to know what that is. Sandstones and limestone. So think about how those form. Know that limestone requires that there be water. So limestone typically forms underwater. It often forms under the ocean. So Florida is made predominantly of limestone, and that tells us that when these rocks formed, Florida was actually under the ocean. So that's important. We learned about sedimentary environments and what different things mean. So we learned about grain size, really big grains like boulders. You have to have a lot of energy to move that. Little tiny grains, you don't have to have as much energy. You learned about if it's rounded or angular. So rounded grains were blown around a lot or moved around a lot. Angular grains aren't. So just know if things are hitting against each other, that's going to round and smooth off. If it's not, then it could still be angular. You learned about mud cracks. That needs to be a wet environment to form. You learned about cross bedding. You need to have wind or water blowing the sediments for those to form. And you learned about fossils. You pretty much only get fossils in sedimentary rocks. You're not going to really find fossils in igneous rocks and metamorphic rocks. Because in igneous rocks, you have to melt and recrystallize. And in metamorphic rocks, you've got a lot of heat and pressure, so you're changing another rock. Sedimentary rocks are the ones that form right in place. So an animal or plant or whatever would have a chance to fall and become incorporated into that rock. So that's why you get fossils in those rocks. Okay, let's see. Aquifers. So we talked about groundwater. And aquifers. So an aquifer is a geologic material that can hold and transmit water. And we talked about which ones would be good aquifers and which ones wouldn't. So in order to be a good aquifer, it has to be porous, meaning it can hold water, and permeable, meaning that the pores are connected, so the water can actually move through the rock. We said that sandstone, conglomerates, and limestone, all of those can be really good aquifers. Limestone, when it's dissolved a lot, can be a very good aquifer. So let's talk about limestone a little bit. As we said, Florida is made up mostly of limestone. And when slightly acidic water hits limestone, it causes the limestone to dissolve. So basically causes holes in the rock. Those holes start out small, and over time they get larger and larger and larger, and they can get so large that the ground can collapse in. That's when you get a sinkhole forming. You can also get sinkholes that just form right on the surface. So that's how you get sinkholes. If those holes underground don't collapse in, you can get caves underground. So caves open up, and then if the water keeps going through, then that calcite that dissolved is still being carried by the water, and it can actually precipitate out into cave formations. So that's how you got your stalactites, stalagmites. Those are both called speleothems, by the way. You get your columns when the two form and they connect. You get your flow stones. You get all of the different formations that you saw in your mastering homework in the caves, and you guys did a nice job talking about them in your discussion board. Let's see. If you have sinkholes, so if you've been to Leon Sinks, and several of you mentioned that you had, if you've been to Leon Sinks and you see a sinkhole with water in it, that means that sinkhole is low enough that it's actually intersecting the water table. So know what a water table is, that above the water table you have unsaturated zone. Below the water table you get your saturated zone. When you watched your video, you had cave divers swimming in your saturated zone. And that, let's see what else do we want you to know about groundwater. I think your mastering had a question about a company pumping water out. So you can actually raise or lower your water table. If you get a lot of rain, the water table will rise. If you don't get rain for a long time and you have water flowing out, with a river or something, the water table will lower. Or if you have a lot of pumping going on, you can actually draw down your water table. So right around your well would be a cone of depression, and you can, over a large area, actually lower your water table. So those are pretty important to us in Florida. Other topics that we talked about, we looked at the rock cycle. So in the very first part of class, we learned about igneous rocks and that you need to have melting and cooling to crystallize out to get igneous rocks. We learned about metamorphic rocks, and the metamorphic rocks we did in this part. And you need a lot of pressure or heat, so you don't actually melt the rock. You just really put it under a lot of stress so that that rock changes. We call it metamorphose, or change. That rock changes. And the third type of rock is sedimentary rocks, and we learned about our sedimentary processes. We talked about those just a minute ago. So each rock type can go back to another rock type like it. So you can have a sedimentary rock that can weather and erode to become another sedimentary rock, or it can be melted and cooled to become an igneous rock. It can be pressed or heated to become a metamorphic rock. Any rock can become any other rock type. All right, and so another section that we have just been working on is figuring out how old different rocks are, or when events happen. So you can talk about how old something is relatively, so something is older or younger than something else. That's relative age dating, and that would be like saying my brother is younger than me. Okay, so that's the relative age, and we had the geologic principles to do that. Make sure you know those and are familiar with those. And then we talked about absolute ages. So that's saying what age am I in years and what age is my brother in years. Those are absolute ages. We used isotopes to figure that out, and specifically radioactive isotopes. So isotopes that decay over time, we can measure how much of that decay has happened, and then calculate back to the starting point. Say, okay, if it's been decaying for this long, then it has to be at least this old. And so we can say a rock is this old based on the amount of radioactive decay that has happened. So be familiar with that and the idea of a half-life. So take a look at those. Make sure you know those. To get our geologic time scale, people used both relative and absolute dating. So look over the time scale, be familiar with it, make sure you are comfortable with that for your final exam. And the last thing that we talked about is changes in the Earth over time. So there are a lot of things. There were tectonic changes that could happen, and there were climate changes that could happen. So we looked at climate changes. We looked at changes in climate in the past and changes in climate that are currently going on. So the video that you watched talked about the ice ages and times of glaciation that we experienced in the past, and it looked at how we learned about those times. So it turns out that when it snows, and that snow stays frozen on the ground, then you get layer upon layer upon layer of ice. And so just like you could drill a core in sediments, you can drill a core in ice. Technically, that's a sediment. So you can drill a core and you can pull it out and you can look at layer upon layer upon layer of things that have changed over time. So watch the video to figure out what some of those things they measured in the ice core were. But by measuring it, we can find out about changes in temperature around the world. We can find out about changes in the atmospheric composition around the world. We can find out about what the environment was like in terms of dust and where dust was coming from. So these are all things we can learn about. And I want you to know those, know a little bit about those, and also know what the ice ages were like in the United States. What features do we have in the United States as a result of those ice ages? What was it like for Florida during the ice ages? What changes happened in Florida during those times? And then what caused that? So briefly, spoiler alert, those were caused by the Earth's orbit. So there are slight variations in the Earth's orbit. We think that we know there are variations, and we think that those variations probably caused these changes in climate. So glaciers grew and retreated, and as a result, sea levels rose and fell. And there were times in Florida where our sea levels were much, much lower. So if you had a lot of the water, and remember hydrologic cycle, if you have a lot of that water locked up as ice in glaciers, then you're going to have a little bit less in the oceans. So sea levels were lower, and actually a lot more of Florida was exposed. What we think of as the shape of Florida now, imagine it as a thumb, and just like I slammed my finger in the door, take that thumb and hit it with a hammer and make it a lot wider than it was because our sea levels were lower. So take a look at that. Know that sea levels have changed in the past, and just like you guys saw in your Miami flooding video and news article, sea levels will change again. If you grow more glaciers, meaning if it gets colder and there are more glaciers, sea levels will drop for Florida. If you melt the glaciers, then sea levels will rise. So these things are related. So know then about modern climate changes. What is causing climate to change currently? What effects do we expect to see as a result of that? And how will that affect Florida? So again, little spoiler because I want you guys to have time to study for your exam. If you increase the amount of greenhouse gases in the atmosphere, and what were those greenhouse gases? Do you guys remember? We had methane, we had carbon dioxide, we had water vapor, were important ones. So if you increase the amount of greenhouse gases in the atmosphere, then you would expect the atmosphere to warm. We can measure that we are increasing carbon dioxide in our atmosphere. The result of the increase in carbon dioxide should be warmer temperatures in the atmosphere, and we can measure that. So if we increase our carbon dioxide, we should expect to increase our temperature. If we increase our temperature, we should expect glaciers to melt. If glaciers melt, then we should expect sea level rise. And you can tie this back to your discussion board about Miami flooding. So the question that I asked you guys earlier about, are we anywhere else like Tallahassee? Do we have any responsibility for sea level rising in coastal areas like Miami? Think about it again now. If we contribute to carbon dioxide in the atmosphere, then we should contribute to increase in temperature. If we contribute to increase in temperature, then we should contribute to sea level rise. So this affects not only the folks in Miami, but all over the world, the lower levels, the lower land levels, right by the ocean, should expect to see change. Now for Miami, they're definitely one of the richer areas in the world where it's happening. It's also happening in a lot of areas that don't necessarily have the resources like Miami does to make pumps and pump it out. So it's just something to consider. Climate has been changing throughout the history of Earth for different reasons, like in the ice ages, and it is changing now largely as a result of the burning of fossil fuels. So you can compare these, you can look at the different things, and we can look at the changes. So these are all things that we have learned about in our class. Go back and review your first section with hard rocks and igneous processes, volcanoes, earthquakes, plate tectonics, planet formation, right? So we had to form our planet before we did all the rest of it. Look at the second stuff with your atmosphere moving, your ocean moving, all of those processes. And then this third part with that movement happening over a solid earth to break down rocks, create sediments, water running down, forming our oceans, and changes in all of that over time, and us being able to measure the time both in relative ages and absolute ages. So that is Earth Science at a glance. I hope you guys have enjoyed the class. I've enjoyed interacting with you all, and best of luck on the final. Remember, it is cumulative. If you have any questions, please email me and or come to my office. I'm happy to talk with you. All right, good luck.